Good afternoon, everyone. I would like to thank the OST, Shared, Picard, PCHRD, yes, for inviting me here. And before I start my presentation, may I acknowledge the presence of the ASTI team who helped me with the research. Please stand. Thank you. My name is Jose Rubrico, or Joe Rubrico. And before I go into what we actually did in ASTI, may I give you a glimpse of what's actually going on now in AI and robotics research.
1, 2, 3, 4. Oh, sorry. My mistake.
Ça commence bien. Allez, l'erreur est humaine. À toi.
Let's start again. 1, 2, 3, 4.
So you will see there the self-driving car, the robot by Boston Dynamics na I think sinali din nila sa DARPA na contest. And you can see there the advancements in AI and robotics in terms of yung sa DARPA robot, yung sa Boston Dynamics in terms of yung dexterity niya. If you have been following the research of robotics since before until now, you can see that that kind of capability is really exceptional. Okay. And kahit yung sa self-driving car, the self-driving car is a very good example of the marriage of artificial intelligence and robotics, because the car itself is a robot. Okay. And then yung music sa background na narinig nyo, that was actually sung by a machine. And it was also composed by a machine. Yes. And here's another example.
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people when?
Next Wednesday at 6 p.m.
Oh, actually we leave there for after 5 people. For people you can come.
How long is the wait usually to be seated?
When tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
Bye bye.
So, question, did you notice anything strange or unusual? No? That's the point. Oh, yes, Dr. Ramon.
The accent is from China.
Thank you.
Yeah, the English accent.
Oh, the other one, yes. Yes, but the point, it was like a very natural conversation, right? But in fact, one of them was a machine. So this is the state of the assistant, the Google Assistant. It is able to make calls very naturally that the East Asian, the person of East Asian descent, as Dr. Ramisola mentioned, couldn't even distinguish he was talking to a machine. So this is the state of the art right now. So these are not real people. These were generated by machines. This was generated by a machine. Okay. These are what we call facial generations by an NVIDIA powered AI. Okay. And in order to generate this, it gathered a lot of faces. Mapapansin nyo, medyo gwapo at magaganda, di ba? So galing kasi sa celebrities yung paggawa. Okay. So another thing that is in development now, or actually it's already being done, but it's a bit prohibitive when it comes to cost, is yung robot surgery. Okay. Another thing is they figured out how to make a machine solve the Rubik's Cube without human assistance. And this is a very, let's just say, challenging feat. And it opens up a lot of opportunities to solve really difficult problems. Because if chess has a big search space, this is even larger. This painting was done by a machine with the style of Van Gogh. Okay, so even in the arts, AI is making an impact already. This is a dream that was generated by a machine. And as Dr. Amisola likes to point out, China is doing a lot of this research now. Okay? If you look at the past papers for the past 5 years in artifact detection from satellite imagery, a lot of them are done by China. Okay. So this is a bit closer to home because we are also doing similar research here. So, more to drive home the point that artificial intelligence and robotics is really poised to pervade our lives. This is the estimate of the worldwide market for AI and robotics in the next 12 years. It amounts to $500 billion. And the top 5 are, number 1, robo-advisor. But this is like, yung sa stock exchange, sa finance. So it takes up more than 50% of that $500 billion. There's a lot of opportunities there. Then sa autonomous car, 80 billion. AI analytics, analyzing big data. Logistics, moving things from one place to another. And industrial robots, yung mga nasa paggawaan ng kotse, mga ganun. Okay. And the next figure shows the revenues from AI from 2016 to 2025. So it is expected that by 2025, the revenues for AI will reach $90 billion US. So major uses of AI right now include image recognition, object identification, detection and classification, and automated geophysical feature detection. And there is a very rapid growth in the industrial robotics scene. In fact, the global industrial robot sales doubled within the last 5 years. So this is just to drive home the point that AIR, or AI and robotics, is really ramping up. So how's the air around here sa Pilipinas? Okay. So, essentially, what we have from my Balik scientist experience is that through the Balik scientist program, sponsored by PICC, the OST PICC and hosted by ASTI, we conducted some grassroots efforts in AI and robotics. And this translated to 2 projects. Project Alum and the AI robot, which is here. Alum essentially is for the automated identification of natural and man-made objects in satellite images. While the AI robot is a prototype for exploring concepts in rescue and recovery robotics and edge computing. So yung edge computing later on siguro i-explain ko ng konti. Okay, so far, there have been a lot of projects sa Pilipinas involving yung remote sensing. Yung satellite at LiDAR data pinaprocess para maging hazard maps, productivity maps, and other applications. And this is mostly a manual process. Involves a lot of people and involves a lot of domain experts. Okay? And it also involves a lot of ground truthing. Yung pupunta ka talaga sa lugar para i-verify. These projects like Project NOAA, UP Dream, PhilLiDAR are actually now they have already been stopped, meaning to say the funding has stopped, but their data is still available. So the projects after the funding is cut generally become archival. Ibig sabihin, meron silang data pero yung data hindi na na-update. Kahit nag-change na yung landscape, kumbaga. Okay. So, let us take a look how it is in ASTI now. So ASTI has a lot of data, especially from satellite imagery and also from project data from LiDAR acquired data. And ASTI also has a very strong high-performance capability and very large storage sa cloud nila. Okay? So, because of this, ASTI has been trying to do some projects like base station identification, rise classification, and monitoring. But the problem is, again, we have limited personnel and processing is mostly manual. So this begs the question, why not use AI to help? Leveraging on ASTI's big data and computational resources. Why don't we use the big data of ASTI and their computational resources to help them automate these things? So enter Project Alum. So this is known as the ASTI labeling machine. The original name is A labeling machine. But Dr. Marciano is the acting director of ASTI said, bakit di na lang ASTI labeling machine? Okay. But eventually, this will become known, hopefully, as the autonomous labeling machine. So Project Alum, essentially the goal is to automate identification of natural and man-made objects in satellite images that could be used as reference data in applications, various applications of national interest. For example, land management, infrastructure maintenance, yung sa DBM, ginagawa ng, tama ba? Budget and management, yes. So what they do is they try to monitor projects via satellite. Okay. So you can actually apply a kind of change detection to see if the projects are really being done in a timely manner. And of course, there is disaster risk assessment and mitigation, agriculture, forestry, among others. So the main idea is you have a satellite image, you pass it through the Alum framework, and then you get a labeled image. Okay, so you label the trees, the roads, the cars. Okay. So the big picture for Alum is that you have a lot of existing process data. But since the projects are no longer maintained, the manpower has drastically decreased. When this part changes, this part doesn't change anymore. Okay? So why not use this part to train as training data for an AI powered model? Okay? And then so that when this changes, instead of going through this pipeline, it goes through this, and then you update the data more quickly. So what has been done so far? So in this case, for this particular slide, I will focus on classification. There are 4 visual perception categories: classification, localization, detection, and segmentation as shown. So classification, you have a whole picture, you tell me what it is. Okay, you predict what it is. So in this case, it's Ellen. Localization, you try to localize a certain feature. For example here, the face of Ellen. for object detection, when you say detect faces, if there are many faces, it tries to box all of those faces. So ang detection parang generalization lang ng localization. And then you have segmentation where you really trace the outline. Okay. So far we have done classification and we achieve a 94 to 96% accuracy for these 4 classes: trees, agriculture, urban, and water. And for large images, what we do is we divide them into small images and then classify each small window and come up with a color-coded, pseudo-segmented image. So this one, for example, is Manila Bay, and this is the pseudo-segmented image. So the yellow part is water, the light green part are the urban areas, etc. So this one is Digos in Davao del Sur, and this is the result of its pseudo-segmentation. So you can see here the water, the shore, the urban areas, some agricultural areas, and some trees. And this is a comparison of 2 architectures that we tested and modified. One is from Cambridge, and the other one is from Google. The right one is from Google. The left one is from Cambridge. Okay. So they have their own strengths and weaknesses. And then, as far as object detection is concerned, this is what we have so far. I don't know why the video is upside down, but we were able to localize object detect faces, let's say, for a group of people. And then for a related, so why do we do this? Well, we do this for the robotics project as well. But for the Alum project, we do this because we were sort of working with PICC for their already finished REDAS project. So REDAS is a project by PICC where they try to estimate human casualties as well as property damage when an earthquake of a certain magnitude strikes a certain locality. Okay. And for this, they need data of the structural integrity of the houses, schools, etc. in a certain place. So the problem with that is it's a bit complicated. So what we did is we simplified their classifications and came up with 5, just as a proof of concept, 5 classes: the strong structure, the medium strong structure, the weak structure, the vehicle, and background. One of the challenges here was that the data from REDAS was already a bit outdated and it needed to be cleaned. And we didn't really have a lot of people in our team. So in the end, we only managed to prepare this much data. In contrast, for our classification problem, we were able to prepare around 100K. So in deep learning, the more data you have, the better results you will get. So this is the distribution. 38% of our data, if we include background, is for the strong structure. Medium strong, 32 or 33%. But really the highlight is that for vehicles, we had very few vehicles in the locality we were sampling. So it's like less than 2%. So this is what we did essentially. We have a picture, a satellite image. You run it through an object detection model, and then you get the same image but boxed. The domiciles are boxed. So in this case, the weak structure is boxed and the medium strong structure is also boxed. And here are some sample results. This one is for a weak. It is identified as weak. This one is correctly identified as a vehicle. This one medium strong, and weak, and so on and so forth. This one is identified as strong. So one thing though is that sometimes there are misidentifications where the background is identified as something. So for example, in this case, these are just trees, but it is identified as a strong structure. So this can be mitigated if we have more data to train our model. So for example, this seems to be the top of a building in flat part. So it is correctly identified, I think, as a strong structure, and so on and so forth. Okay, so since there are 2 tracks and we have not so much time, I go to the AI robot. The idea for AI robot is to develop a small team or a core team of robotics researchers in ASTI who are also versed in deep learning, so that we could make a proof of concept for rescue and recovery robots. The idea is that if in the immediate aftermath of a disaster, let's say an earthquake or a storm, a typhoon, it is not really very safe to send people right away because the land might be soft, the rubble might fall. So it's actually better to just send a lot of robots there. Okay? And what the robots can do is you can equip them with some deep learning intelligence wherein they are able to detect people, okay, from using their camera. So in order to make a robot, you need all of these things. By robot, I mean mobile robots that move around like this. Okay? For the Balik scientist prototype, the underlying things were what we were able to implement. We wanted very much to implement point cloud mapping so that we could have robot localization and navigation, but unfortunately, this LiDAR module costs more than first what I could afford, and it would complicate the procurement process sa government too much. So we just opted not to include this for now. Okay, so the robot functionality without the LiDAR would be just like the robot would roam around with some sensors that will help it avoid obstacles, and then once it detects a person, it will, well, supposedly inform an operator or inform another robot that it detected a person. So in this case, for this robot, it will be tutunog lang siya. Okay. Okay. So we actually introduced 2 concepts of how to implement this robot. One is using off-board or fog computing. So fog is not exactly a cloud. It's smaller. So when you say cloud, usually pag Amazon, ang dami-dami nilang computational resources. Yung Google, ang dami-dami nilang computational resources. But in our case, we only wanted to use one PC, which had a GPU. Kasi walang GPU yung mga nandito kasi. So, ang tawag dito, fog. So, maliit siya na cloud. This was one design concept. The other concept was that, why not just put the capability of doing deep learning dun sa robot mismo? And this is what we call edge computing. Doing all of your calculations on the edge means doing all of it on the device itself. So this is what we will show today, and this is what we implemented. So this is just an overview of what the robot is, yung structure niya. So basically, it is composed of 2 Raspberry Pi computers, and it has also an Arduino somewhere there inside, and it has a camera, it has infrared sensors and ultrasonic sensors. And also it has this neural compute stick, which allows us to do deep learning predictions on the Raspberry Pi. The AI robot project was also an opportunity to introduce the robot operating system, which is actually an industry standard and an academic standard already around the world, but it's not so much used here in our country yet. Okay. So with ROS, you can sort of standardize the way you create the robot architecture, the control architecture, and the way you get data from the sensors. One of the main takeaways from that is that if you need a module, you don't have to reinvent it, but you can download it somewhere. A module that works has been tested by many people. And if you want to share your module, because you are using a similar architecture, you can just upload it and other people can use it as well. It also allows for visualization and simulation of your robot. So, for example, hindi namin magawa yung, kasi wala kaming LiDAR, hindi namin magawa yung localization tsaka navigation on the real robot, ginawa na lang namin sa simulation. So, ROS allows for that. Okay, so now we go to the demo. First, the video demo.
I thought.
Hindi namin magawa sa actual robot, so we did it in simulation. So in this part here, the robot is trying to localize itself and at the same time map its environment using a LiDAR or laser sensor. So before I go to the live demo, to slide forward, please. You may thank you. I will leave you with these words. So, he is a controversial person, but I think in this case he said something wise. Okay, so ask the team, please. We go to the live demo, the robot.